Praise be the Lord. And welcome back again, guys, to this third class of mathematics. In this case, we're going to talk about a specific conic section, in this case, the parabola. What we will do, we will determine the cases of parabolas. We're going to get the element of a specific parabola. We're going to graph a parabola in a coordinate plane. And we're going to conclude about the procedure of possible cases about the parabola. Okay, you already know something about it. You already know the definition. I'm going to review it. You already know something about the elements and, of course, about the graph. So we will do today one graph of a specific parabola. You will see how is the procedure. And in other classes, we're gonna practice a little bit more. Okay. So parabolas in real life. Where can we see parabolas? For example, when you are playing basketball or volleyball, you throw the ball goes up until one moment, stop, and then starts like going down in same behavior as it goes up. What about this other example? If a dolphin jumps from the water, the dolphin reaches like a maximum high and then starts falling down. But it falls down at the same way it goes up. And this last one related with technology, sorry, is more interesting because practically with this parabolic antenna, we can describe how is the parabola. For example, the signal comes here and is received in this small plate. Then it's transmitted to this point in here, which is practically the focus of the parabola. And this focus return down, return again this signal to the plate receive and capture that signal. That's how the internet goes to your house or the signals work maybe have flight or behaves. Okay, so here's a little description of the parabola. As you remember, the definition said that the parabola is made by all the points that are equidistant from the focus, that have the same distance to the focus and to the directrix. Here is one example. I'm going to choose this point of the parabola. Of course, it's already a point on the parabola, but if you see the distance I'm making right now will be similar, will not be similar, have to be equal to that one. Okay, even if you see, it's not exactly, but if you see they are too similar, right? What about this one? This point is exactly on the parabola too. So that distance from the focus to there must be the same distance from that point to the directrix. And remember that points from to a line, the distance from a point to a line is the perpendicular, sorry, is the perpendicular segment. And if you see now, those looks like very similar. What happened with one point that is out of this parabola? What about that one? If you see here, the distance not like too long, but if you see now the distance from here to the focus, it's longer. It's longer. I think you can see very easy that here is like, I don't know, 2 centimeters. Here is like triple of that, 6 centimeters. So that point is not part of the parabola and it doesn't fit in the definition too. Okay, I think you're clear with the definition of parabola. So, important characteristic of any parabola. All parabolas in the formula contains a quadratic expression. The equations contains x and y variables, and one of those will be to the second power. Here is one example. X to the second power, it's equal negative 12y. As I told you, one of those x or y will contain the second power. Here is the graph of this expression. We're going to do it later from 0. We're going to see why that graph or why this equation behaves like this graph, which is at the end what we want. Make the graph of one parabola as one of the objectives. So there are the elements of the parabola. I'm going to use this example. And if you remember, any parabola has a vertex. The vertex is practically where the parabola begins. And we can define this like the midpoint between the focus and the direction. The focus The focus is one of the most important points in many shapes because it helps you to describe how it's going to be the shape. And of course, the directrix, which in this case is that red horizontal line, that will help you with the focus to conclude the points that are part of the parabola. So formulas for parabola. Here I describe the parabola in four cases. We will see these four cases later. And if you see for each one, we can get the vertex, the focus, and the directrix, which are the elements that we require at the moment of the graph. If you see here, there are cases with y at the end, with y practically related with the second power, and two cases related with x to the second power. You should screenshot this in order to have it like a index card or use it later for homework or for investigation, for classwork you will do, okay? So in all formulas, you must consider the value of a as a positive number. The negative sign is part of the formula. Okay, be careful with this because in all the negative, in all the formulas, I mean, these negative signs are not like part of a or in this case of 4 or of h. No, this is like a minus in the formula. So at the moment you take the value of h, we just will take the value like it is, not with that sign. We will see some specific cases when instead of have this minus, we have a plus. We have to do a little change and then we're gonna get the answer. But be careful with this. And again, the value of A is always considered positive. Don't look at that one like a negative because if you choose A like negative, then these formulas will not work. A is the half of the distance between the focus of the parabola and the directrix. Don't get confused this with the vertex that I said because vertex is a point, is the midpoint I said. But A, which is a positive number, is related with the half of the distance between the focus and the parabola. It's very important you keep in mind this because later on we will see a case where you have to make or you have to build an equation of one parabola knowing the graph. Right now, we're gonna do knowing the equation, make the graph, but then we can do the procedure in different order or vice versa. So here we have each of these cases related with the corresponding graph. And for example, that one, the first case will be a parabola that opens to the right. The second case, a parabola that opens to the left. The case 3, a parabola opening upward, and the case 4, a parabola opening downward. So we will see how this happens in our in one example in our parabola. I mean, one example we're going to study, which will be the one at the beginning. That one, x squared equals negative 12y. And I'm saying that this fits in the fourth case. Reason is x is to the second power and the 12 is negative. Okay. In which this one, the x is related with the second power in the case 3 and the case 4, as you see. In which those have equals to something negative with the y. In this case, is the fourth case. That's why it fit in here. As I'm telling in here, x is squared and the y value is related with a negative number. And the equation right now, like it is, x squared minus 4y doesn't look similar to this. Okay, they don't look like, I mean, here you see a negative 12, here is negative 4a, here you have x squared, but here is x minus h. So how can you get this? It's very easy, but careful with something. These cases are not common. I'm just showing you this one because it's simple. It's like the simplest case to see. It's the simplest case to see because the vertex will be in the origin. But how do I know that? Okay, I don't see it, but here the value of a is 0 because x minus 0 doesn't affect anything. Minus 0 is x. The same is gonna happen here. Y. Y is the same as y minus 0. That's why I prefer or I write this expression instead of just x like x minus 0 instead of just like y minus 0. And if you see now, this looks a little bit exactlier than this, but not at all because of this negative 12. We're going to see what happened with that negative 12 now. Knowing that, this is still being the fourth case, we see that this negative 12 is like our travel. I mean, we want to have something like negative 4 or minus 4, and then the a. What's going to be the value of a? Okay, for a is like negative 12 in the equation, like I told you, but negative 12, here it is. Negative 12 is the same as negative 3, sorry, negative 4 times 3. So we can change that instead of negative 12. So instead of negative 12, we're going to write negative 4, or in this case, minus 4 times 3. Again, and be careful with this. I'm doing this because I want to make as possible as I can to this equation looks too similar to that one. Don't say that it's impossible. Then I'm going to show you a trick about how to get those numbers. It's very simple. It's very easy. Okay, with this information, now you can proceed to make the graph of the parabola. Of course, you have to get the element first. But with this information, like you have it right now, you can get that these elements we want. And that's what we're going to do. So knowing this, with the equation, we can conclude many of the values in the formula, and this will give us the position of each one. I mean, those values are related with a specific position. If you remember, the letter that goes in here was H. If I'm wrong, here it is. H, the value that goes in here, that's 0, is K. The value that goes in here is A. So we can conclude now that the values of H and K are 0, and the value of A is 3. If you're not clear at all right now, don't get confused with the negative signs again. These negative signs, or these minus, are part of the formula. H is the same as 0 in here. A is the same as 3 in here. And K is the same as 0 in this part. If you see, they fit exactly in the same position. Okay, so be careful with this. And of course, later on, we're going to see other cases more interesting and more difficult to see how can you get specifically those values. So knowing these three values, we can conclude now the elements and graph them in order to make the parabola. This is what we're going to do right now. Of course, here you have the elements. You're going to talk about the vertex here, you're going to talk about the focus here, and you're going to talk about the directrix in here as we have it in the table. So this is the information we have, and we can conclude now. The vertex will be 0, 0. Why? Because the value of H is 0, value of K is 0, and the vertex is H, K, so it's going to be 0, 0. The focus will be H, K minus A, so it's going to be 0, 0 minus 3. So at the end, the focus is 0, negative 3. And this one, the directrix, I'm going to explain you something about the directrix right now. The formula says you have to add the value of K plus 3, or the value of K plus A. Here it is, the directrix. And you're going to add 0 plus 3, which is 3. So what means y equals 3? Y equals 3. I'm doing a Cartesian plane. I'm sorry, this is not exactly, but it's just to explain you what means y equals 3. Y equals 3, it's a horizontal line that will passes to 3. Okay? What happens if you have y equals negative 4? So it's going to be a horizontal line that happens, that passes, through negative 4. What happens if instead of y equals, we have x equals, because it's another case? What happens if you have, for example, x equals 1? Doing another Cartesian plane, we will see that those ideas are very similar. And the idea of have x equals 1 is that you're going to have a vertical line that passes through 1. This idea is very important to keep it in mind because it's going to be useful at the moment to graph the directrix. Knowing this information, now we can pass to a Cartesian plane in order to see how to make the graph of this parabola. It's very simple. Okay, let's make it. Just keep in mind that the vertex is 0, 0, focus is 0, -3, and the directrix is y equals 3. Okay, here we have our Cartesian plane ready to make the graph of this conic section, in this case, that parabola. We need to graph first the vertex. So the vertex, it's a point that will be in the origin in 0, 0. Where 0, 0? Exactly there in the center. What happened with the focus? Focus, if you don't remember, was 0, -3. If you think the point goes here, you're not clear and you have to review again the first class, because this is -3, 0. 0, -3 is here because the value of y is always in the second position. Don't forget that. So we already know that one, and is missing the directrix, and that directrix, I told you, is a horizontal line that will passes to the value that is mentioned. Of course, this horizontal line is supposed to be imaginary, right? But we're gonna do it like this right now in order to show you how is the parabola in essence. So I'm gonna do something, and is that I'm just gonna trace the parabola. One situation here. This fit in the fourth case, and if you don't remember as well, the fourth case, the graph of the fourth case goes like this, downward, and it has sense because the points that we can make that will be equidistant to the focus and the directrix will fit in a way that opening downward. I mean, if you open this upward, then the distance from here to one point to the parabola will be longer than the distance from that point to the directrix. So it doesn't fit in the definition that we said. So the only thing you need to do is have clear in what case you are, and I'm not gonna ask you for exact clear graphs. So I'm just gonna do the parabola, trying to do my best, of course, and trying to respect the information that I have. So the parabola we're gonna make, it's gonna be like this. Could be better. But at the end, that's what I'm gonna ask you to. I'm not gonna ask you for exact clear graphs. To do exact clear graphs, we have some application. I'm gonna show you one right now. And this expression that we have right now is the parabola. So of course it looks better in a website. I mean, in an online application like this one, which is called Symbol Lab. I recommend to you look for it. It helps you to with many things of math and of physics too. But right now we're gonna plot in here as exactly as it is the graph of this function. And if you see, here it is, right? If it's not clear, I'm gonna show you the focus, which was 0, -3. The directrix, which was y equals 3, and of course the vertex, which is 0, 0. You can use this one to check your work, okay? Because this is an online application, it makes this exercise, of course, exactlier than this, right? But I do my best. I did my best, I mean. So this is all for today, guys. Thank you for your time and continue studying. There will be an assessment related with this for next week. But the most interesting thing we will do next week is a Zoom session related or open session for you to make questions. Okay, so it's gonna be, I think, on Monday, and then we will have the next class. Okay, so thank you for your time, and I hope you are getting the ideas or understanding this topic. Bye bye.